Next one, the terms that we are using to explain the coordination complexes. Okay, so in case of coordination complexes, we have different terms. What I said before, the ligands, right? This is a term using in coordination compounds. So we have different terms. The first one is coordination entity. Coordination entity means the things we are writing, means the metal and the ligand together. They are called coordination entity. Suppose I am writing C here, COCl3NH3 thrice. This is a coordination entity. So whatever you are writing outside the square bracket, that is not coordination entity. That is ionization sphere. Okay, suppose I am writing one complex CONH3 6 times. Now I am writing outside, that is Cl3. So here you can see this is the coordination entity. This chlorine is not belong to the coordination entity. Okay. Now, central atom. Central atom means whatever you are writing in the middle. That the metal atom itself is called the central atom or ion. Then which the number of ligands or group is bonded, means the metal to the metal atom the ligands are connecting. The ligands are connecting to the central metal atom. Okay, so they are also called as Lewis acid. Lewis acid means, what is Lewis acid? Lewis acid means they are acceptors of electron. Lewis base means they are electron donors, right? So in case of coordination compounds, how this bond is forming, that we will discuss in the next topic. Before that, normally the bond is forming like the ligand is giving electrons to the metal atom. Okay, that's why they are called coordination compounds, because coordinate bond means the bond that is formed by the sharing of electron, but here only one atom is sharing the electrons. Other atom is not sharing the electron. So in case of this coordination complex, you can see the ligand is normally two electrons they need to make a bond, right? This bond is formed by the sharing of two electrons, but here this ligand is sharing both the electron to the metal. So normally we are denoting the bond like this with an arrow. It means the ligand is giving electron pairs to the metal atom. Okay, that's why they are called coordinate bond or coordination compounds. So metal is accepting electron from the ligand for the formation. Actually, metal is not sharing any electron. Ligand is sharing both the electron for the formation of bond, because one bond means there should be two electrons. So that ligand is sharing electrons, both the electrons to metal. So metal is Lewis acid and the ligand is Lewis base. Now the ligands. So ligands means whatever they are surrounding the metal atom, maybe single atoms or neutral molecules or group of atoms like that. So the positive, negative or neutral molecules or compound having the lone pair of electron is called ligand. So as I told, H2O, Cl minus, all of them can be considered as ligand. If you consider H2O and NH3, on NH3 there is a lone pair of electron. This lone pair of electron they are giving to metal. If you consider H2O, there is two lone pairs of electron. From that, only one lone pair of electron they are donating. Okay, so if you are considering chlorine, chlorine has three pairs of electron and they are donating one pair. Any halogen, if you take the same way. Okay, so these are the different ligands. Now the next term that we are using is coordination number. Coordination number, as I said before, they are the number of ligands connected to the metal atom. So here in the previous case, you remember I said in case of the first one, COCl3NH3 thrice, means here the coordination number is 6. If you, the chlorine is not, means it is not along with the solid line, it will be in the oneness theory we discussed, right? So coordination number means the number of ligands which is surrounding the particular metal atom. That is called coordination number. Don't consider the ionization sphere as the coordination number. Okay. So here the coordination number is 6, 3 plus 3. Okay. Now, next one, coordination sphere. The same thing. The what we are writing inside the square bracket is called coordination sphere. Means the things we are writing means the metal and the ligand. This is the coordination sphere. Okay, the things we are writing outside, suppose we are writing chlorine, anything, that is called ionization sphere. Okay, next one, coordination polyhedron. So coordination polyhedron means, suppose I am taking a coordination compounds, M is the metal, L is the ligand, which is surrounded by 6 ligands. So these 6 ligands can be arranged around the metal atom in a special geometrical manner. So that the complete geometry we are getting is called coordination polyhedron. So here the metal is there, which is surrounded by 6 ligand in octahedral way. Okay, so this octahedra is the coordination polyhedron. Octahedra means 4 will be in the plane, 1 up, 1 down. That is called coordination polyhedron, octahedra. So all the coordination compounds have their own structure, that is called coordination polyhedron. Okay. Next one, the term that we are using is normally oxidation number. Oxidation number means if the primary valency in Werner's theory. So every complex in the metal should have some oxidation number, right? So that oxidation number means plus 3, plus 2, any number. That is called oxidation number of the central metal atom. Now, homoleptic and heteroleptic complexes. Okay, suppose in some complexes you can see in the example that we discussed before, CONH3 thrice Cl3, and other one CONH3 6 times Cl3. So what is the difference between these two complexes? The first complex is heteroleptic complex. Means here the 6 ligand, coordination number is 6, right? But here we can see both the ligands are different. Okay, they are called heteroleptic complexes. If the metal atom is surrounded by two different types of ligands or more than one type of ligands, they are called heteroleptic complexes. If they are surrounded by only one type of ligand, they are called homoleptic complexes. Okay, so that is the difference between homoleptic and heteroleptic complexes. Now, some questions. Give one coordination compound with the ligand coordination number 6. Coordination number 6 means, see, ethylene, one ligand is enough to donate 6 pairs of electron. See, one coordination compound with only one ligand having coordination number 6 means this one ligand is enough. Normally, in case of NH3, they are giving one pair of electron. Okay, in case of H2O, they are giving one pair of electron at a time. EDTA means that one ligand can donate 6 pairs of electron. That is EDTA. Okay, so the another one, ethylene diamine is there. They can donate 2 pairs of electron. They are called bidentate ligand. This is called hexadentate. That we will discuss. Okay. So next one, ligands are occupied in the coordination sphere, whereas counter ions are occupied in the ionization sphere. What I said. See here, suppose CONH3 thrice Cl3. This is normal complex. Another one, CONH3 6 times, and outside the sphere I am writing chlorine. This is called ionization sphere and this is called coordination sphere. So the things we are writing outside that is undergoing ionization is called ionization sphere. Okay, so that is the different things regarding the terms that we are using in case of coordination.